The next speaker will be Jaakko Särelä, who is now at Reactor. We have long history with Jaakko. We were born on the same day in the same hospital, so I've known him for about as long as you can. Now that Jaakko is back to Reactor, so he was working at the Curious AI company for a while, as you knew. He's been working on a very interesting project where you try to figure out how the prices of houses, or like where does the price of the house come from? This is something which I think has clear value for many of us even. So I'm looking forward to hearing where I should invest.
Yeah, thank you, Harry, for the nice words. So let's see. Yeah, so as Harry mentioned, I'm working at Reactor as a data scientist, and it seems a bit unbalanced, but maybe I'll get adjusted to how it works. And today I'm going to speak about kannaattaakokauppa, so how to calculate the mean apartment prices in Finland in every zip code. And Reactor is a creative technology company, and there's almost 400 employees there, and we are creating digital services for our customers. So we are mainly a consultant house and in many areas. And there's as well data science and big data part in the lot. In addition to consulting, we have some like spin-off ideas, so product ideas. We've done algorithmic trading, and now we have a space company, which is a spin-off from Reactor. Just a few words about data science. There are kind of many terms like big data, data science, machine learning, AI, and all of them are somehow overlapping, and nobody has a clear view of what is what. But with data science, we mean data-oriented solutions for customer business development that use, for example, machine learning and big data. And we do modeling and testing, and we think that solutions that are grounded in statistics are better in the long run for the customer than just some ad hoc solutions. And we use tools like R, Python, Hadoop, Spark, etc., etc. We are currently about 10 data scientists. Most of us have PhDs, and we have a lot of experience both in the academia and as well in the private sector. And there are some applications I just listed, like personalization and recommendation systems and all that. We've done projects for example, Yle, Veikkaus, Stockmann, Samsung, HBO, and others. Okay, but now to the main topic today. So kannaattaakokauppa. This is an attempt to model the apartment prices in Finland, and so this is an interactive map. If you go in kannaattaakokauppa.fi, then you can go on clicking each of the hundreds of postal codes in Finland to see how the prices have been, and there's as well some prediction in the future, but because predicting the future is a bit difficult, then I'm going to concentrate on kind of predicting the past. So how to tell what the mean average apartment prices in each zip code have been for the past 10 years. And what we have as a data that we use is that we have these yearly apartment mean prices for the postal codes from Statistics Finland, and these are censored in such a way that if there's less than 5 apartments sold in one given postcode, then no data is published there. And then we have this population density for each zip code as well. This is from Paavo. There's a lot of other variables there too that could be used as well. And then we used for visualization this postal code area map. This is by Dukis, so thank you Dukis for that one. And so it kind of seems that, okay, predicting the past, that's not very interesting, but it's actually rather difficult because on the right here you see the mean apartment prices in each of the zip codes. They are colored so that the lighter the color, the higher the price. And if this works, then it didn't. What do I have to do? Yeah. So there's the yearly evolution there. And you can see that there's a lot of missing data. There are a lot of zip codes that don't have any sold apartments, or less than 5 in a given year, and there aren't even many zip codes that don't have any sold apartments in any of the years in the data. So, for example, if you would like to know what's the mean apartment prices from the year 2005 to the year 2016 in Renkomäki Ämmälä, which is near Lahti, then there's actually the case that there are no apartments sold during that time. But anyway, we would like to see what's the kind of, have some kind of an estimate of the mean of the prices, and what's the trend. Are the prices going up or going down, or how has it been in the past? So of course one idea that probably comes into anybody's mind as well as mine, and is this, that we could use the sold apartment prices from the neighboring zip code. So for example, here we have Launen-Nikkilä, which is a neighboring zip code. We have Möysä, and then there's Villähde, and all of these have sold apartments. So we could have some kind of a method that puts this information together to arrive at, if somebody would sell an apartment at Renkomäki Ämmälä, then what would the price be? And of course, there are many other parameters as well to the prices of the apartments. So here we have only looked at the kind of total population of apartments in the zip code that are sold. So of course, small apartments have higher prices and per square meter, and as well the production year of the house affects and so on and so on. But this is like bundling everything together and then just trying to estimate the total of the prices. But even this one is not trivial. So if we do this kind of averaging from the neighboring zip codes, how should we do it? So, for example, in this case, the prices are increasing in Möysä. There's a bit more apartments sold there than in the other neighboring zip codes. And then the prices are decreasing in Launen-Nikkilä. So how do we know in Renkomäki Ämmälä? How is it? Is it like similar, or what should we do? So what we do is that we use the additional information that we have about these zip codes. So in this case, it's the population density, but you could augment from Paavo all kinds of other parameters as well, and use all that to kind of come up with a solution that somehow optimally balances between these neighboring zip codes. This is exactly what we did. The model that we use, it has a quadratic model for the time. So from the right, when you see now the estimate of the price per square meter per year. You can see that it's a quadratic function. Of course, it has its limitations if you consider predicting the future, because then always the prices are either going up or going down if you go forward as enough years. But for predicting the past, it's actually quite good, and from one year to another, the price evolution is quite smooth anyway. And in addition, we use 3 levels of hierarchies for the postal code. So we use the actual zip code, which is in this case is 15680 Renkomäki Ämmälä. Then we use the next hierarchical level, so 156, and then the last 2 can be anything. And then you have actually 2 zip codes, which is Renkomäki Ämmälä and Launen Nikkilä, and then even a higher one, 15XXX, and then you have, for example, Lahti and the others. And then we use the population density, actually for the middle hierarchy in this case. And I wrote down here the model for the log price per square meter on the lowest level. So it has the parameters for the zip code itself and the time evolution, and then from the higher level of hierarchy, these density parameters, and the distribution of the log observations that we have are t distributed. So this is like estimating the Gaussian variables in case where you have only a few samples. And then we used rstun or stun to actually do the estimation. So it's a probabilistic programming package where you just write down the generative model, and then it does the MC sampling for you. So it's quite flexible, and it has a nice interface to R scripting language. And with all this, then we get the price estimates for Renkomäki Ämmälä. So it says that in 2005, the average prices were close to 1,250 euros per square meter, and then it went all the way to above 1,500, and now it's probably coming a bit back to closer to the 1,000. And here's, I wonder if it started. Yes. Now on the right you can see the average prices of all the zip codes, even if the data is there's a lot of missing data. And if you want to know more, then you can visit, I don't know, it's quite small, but if you visit reactor.com/datascience, then you'll see some more examples of what we have done. Thank you. Yes, maybe some questions. Please. Sorry, can you speak a bit louder? Oh, far north. So why are the prices increasing in far north? In Sodankylä there was a mining expedition, but now the prices are actually going down. So that ended. But there was all the apartments were in use, and there were the workers of the mining expedition. They were living in mansion houses, and so because Sodankylä is just a small place. So that's the reason for that one. There, either one.
So what's the population density like the best feature you could think of based on you find?
Yeah. Well, I think it's a first order approximation to the like what's the area like. So I think that optimally I would use some like more spatially kind of distributed factor. So because if you have a low density area very close to a large city, then that's quite a different thing than having a low density area somewhere where everything is low density. So of course this is a bit kind of covered by using the middle hierarchy, but you could have a kind of more like a spatial map.
Did you run any accuracy metrics after you got the new prices for 2015?
That's still working in the progress, so no for the kind of future predictions. Yeah, but I think the trend that we saw 1 year before, it has continued. So I believe that they are actually pretty accurate. So at least there are no very big changes, so that areas we predicted that the prices will decrease, that they would be increasing, and vice versa. Please. Sorry, can you speak a bit louder?
Similar question. So how is the accuracy when you run it on the historical data?
In the historical data, there's kind of question of what do you mean by the accuracy? Because there's of course variation if there's, in some zip codes, if there's something like 7 apartments are sold yearly, and if in 1 year all of them are old apartments and the next year all of them are new apartments. So then it could be that the kind of average price of all the apartments in that zip code, it has kind of progressed according to the trend, but there could still be a large kind of diversion from the mean in the data that we see. So in that way, that's not a good measure. And actually, there have been in the newspapers, there have been a lot of these lists about prices in zip codes, and they have reported something like 30% price increases in 1 year, and of course that's just ridiculous. So it's not a trivial thing of how to measure the accuracy of even the past, so and let alone the future. Okay, please.
Did you try any other modeling techniques? For example, would Gaussian process regression be feasible here with coordinates and year and size and whatsoever as an input?
Yeah, I think that that's a valid option. I think that in this case you need some kind of a hierarchical model. But if you have that, then there are several approaches. You could have a kind of more like a spatial Gaussian field type of model. And I guess there are many variants. No, we didn't try any others for this one. Okay.
How popular is the search? It's very popular. You may even be like creating the price.
Yeah. Yes, it has quite a lot of popularity, and we even made it to the front page of Iltalehti last year. And there was actually a guy from Tervakoski called me when we launched the service last spring, and he was complaining he had a omakotitalo, he had a house in Tervakoski, and then he said that our service gives lower price per square meter than what he had used for building the house in 2009. And then he was afraid that people are starting to look at this and then they don't want to pay more than what this service shows them. So of course I tried to calm him down and said that maybe in Tervakoski most of the apartments are in old houses, and if you have a new omakotitalo, then that's probably a bit more valuable. But what I didn't say is that I don't consider Tervakoski as a very good place to invest currently. Okay, still some. There was one there back. Or yeah. Okay, if you know other questions, then thank you.